right, everybody. So homework is out, and as soon as you get the lights off, make sure you got your phones, earbuds, all that kind of stuff away, please. So I really don't want to take it down to the dean's office. No fun. What happened? It's tripping? All right. How did that homework go? Good. So let me just run through. Let's see. Problem number 1. That would have came out to 2 to the 5th, which is 32 if you worked it out. Number 2 is 2 to the 6th, which is 64 if you work it out. And then here's where the first questions start coming in. Do we have to work it out? And I would say sometimes. Like if you had 15 to the 7th power, that's going to be a number that you won't be able to work out. But like if it's 2 to the, 2 up to like the 5th or 6th, you can probably work it out. Then we get to problem number 3. We have 3 squared and 4 squared. They're being added together. Well, what's 3 squared? 9. What's 4 squared? 16. If you add 9 and 16 together, you get 25. Problem number 4, you have 3 and 4 grouped together, and then the whole quantity is squared. So we would have to add the 3 and 4 together first, which gives me 7, and then 7 squared is 49. Problem number 5, we have -6 in parentheses, and it's squared, so that comes out to positive 36. In problem number 6, we don't have the -6 in parentheses, so the 6 is the only thing being squared. So problem number 6, the answer is actually -36. So double check 5 and 6 that you have the correct answer and that you understand why. Are there any questions on 1 through 6 that you need me to clarify a little bit more? I know there's some further down that I need to clarify, but 1 through 6, are we okay? Yeah.
What was number 2 again?
2. That's 2 to the 6th, which would be 64.
Okay, why would it be 2 to the 6th?
Because power to power, the exponents are on top of each other, so they multiply.
Oh, okay.
And which one did you say, Tayshawn?
3.
3, that's 9. 9 plus 16 is 25. Because you can go 3 squared and 4 squared. What? 7 to the 4th.
What's number 3?
Is it okay if I do?
Number 3 is 3 squared, which is 9, plus 4 squared, which is 16. So 9 plus 16 is 25. Yeah.
Is it okay if you do it right on my
Can't see that far. Yeah, that's perfect. Yeah. Up through number 6 it is? Okay. All right. Let's take a look at 7, 8, 9, and 10. So you have to think about it. If I were to raise 10 to an exponent, I know that 10 to the first is 10. 10 squared, so 10 to the second is 100. 10 to the third is 10 times 10 times 10, which makes that 10 times 10 is 100. 100 times 10 is 1,000. So on number 7, your n value, your exponent, so the variables being an exponent on that one, is going to be 3. So 10 to the third power is 1,000. So 3 is the answer.
Yes. Well, I did like the 10. So I thought that
Good.
was right.
No, I totally accept it. 7. Then number 8, I have 4. 4 raised to what power gives me 2, right? And then number 9, we have 2y equals 64.
16.
So
Yes.
what? 2 to the 16th?
Yeah.
Okay. Let's see. So let's do this. I know that 2 to the first power is 2 times, it's 2. And then 2 to the second is 4. 2 to the third is 2 times 2 times 2, so 4 times 2 is 8. 2 to the fourth is what? So it's going to be 2 times 8, which is 16. 2 to the fifth, it's going to be 2 times 16. What's 2 times 16? 32. We're not quite there yet. And then I have 2 to the 6th power, which is 2 times 2 times 2 times 2 times 2 times 2. So what's 2 times 32? 64. So what is the answer to this problem? 6. So right here, that is, so your y value is 6. Yeah. Nope, 2 to the first, you're only talking about 1, 2, so it's just a singleton 2. It's like 2. Okay? Yeah.
Can't you also take problem number 2 and then you can
Yep, you could have. Exactly. So you spotted that one above. Good deal. All right, and then number 10, and this will be one we'll talk a little bit more today. Okay? So I have 5 raised to the n power is equal to 1/5. And this is something that, like, they'll throw a problem like this at you on the, bless you, on the PSAT, the SAT, and the ACT. And a lot of times you look at that and you're like, whoa, I have no idea. So I'm just going to tell you that 5 raised to the negative 1 power is 1/5. And we'll keep that as the answer, but we'll explain that later today. Is that all right? So a negative exponent means that it kind of switches from a denominator to numerator or a numerator to denominator, which we'll cover more later. Okay? Are we okay up through number 10 with number 10 knowing that we'll be explaining it a little bit more later? All right, number 11. Like bases, I add the exponents. So what's my answer to number 11? Y to the 8th, right? I add the exponents. Number 12, like bases being multiplied together, I add the exponents. What's the answer to number 12? X to the 10th. Number 13, I have C to the 6th and C. And C sits there all alone. What does C really raise to? The first. So what's the answer to number 13? So yeah, C to the 7th, because you had C to the 6th times C to the 1st. So that's C to the 7th. And then number 14, I was hoping you could decipher it because, you know, with the information I gave you. So you have all of those. You're like, but there's a negative exponent, so I don't know how to do it. Well, you do know how to add and subtract positives and negatives. So if I add those together, what's negative 2 added to the 7? 5. And what is 5 added to 3? So this answer is y to the 8th power. Okay? Is that all right up through 14? And then number 15, power to a power, they're on top of each other, so they multiply. Number 16, power to a power, so they're on top of each other, so you multiply, so I get x to the 24th. Is that all right? And then number 17, yeah, they're negative exponents, mister. Well, you know how to multiply negative numbers together, don't you? So it's a power to a power, so I multiply the exponents. So what's negative 3 times negative 2? Positive 6, right? So this comes out to an answer y to the 6th. And then number 18, hey, mister, you never told us we get our fractions as exponents? Sure. So they're like bases, so what do I do to the exponents? Add them. So I have 1/2 plus 1/3. Okay? Yeah, you can get the common denominator of 6, or you can do it my fast way. That's 3 plus, that's 2, over, that's 6, 5 over 6. So this yields me an answer of c to the 5 over 6 power. Yeah, they should always show you. They should have taught you how to do that way back in the day. Unfortunately, I didn't. But I'm happy to show you that anytime.
Will that be on the test? Will that type be on the test?
Oh, I don't know. I haven't made the test yet.
Oh, yeah.
But because you asked, the whole test is with. All right, 19. Number 19. So this is where students, if they hadn't fallen off yet, will probably start to fall off, and that's okay. So what do I do with the 3 and the 8? I multiply them, right? This is a multiplication problem, so you multiply those together, so that gives me 24. Is that okay so far? Now I have like bases that are being multiplied, x to the 4th, x to the 6th. That gives me x to the 10th, and I'm done. Yeah, because 4 plus 6 is 10, right? And then number 20, I get negative 3x to the 11 times 4x to the 15. Okay, so again, this is a multiplication problem. So what's negative 3 times 4? Negative 12, good. And then I have x to the 11, x to the 15th, like bases being multiplied, so I'm going to do what's the exponents. So 26, I'm going to add them, right? So negative 12x. Hey, quick question. How are these being held together right now? Multiplication. Do I have to put a multiplication sign in between them? No. If you do, it's fine, but just realize you're using x, so if you make the multiplication sign an x, then it's like, oh, you have all these x's. So be careful. I'm cautious on that. All right, 21. Negative 3x to the 4 times 5x to the negative 6 times 2x to the 7th. So I'm going to multiply this and this and this together. So what's negative 3 times 5? Negative 15. What's negative 15 times 2? Negative 30. Everyone okay still?
21 and 22 are the same.
Oh, cool. So we don't have to do 22. Good deal. All right, so is everyone okay with the negative 30?
Yeah.
All right, so now we're going to add the exponents. So 4 minus 6 is negative 2. Negative 2 add to 7 is 5. Let me walk one more time through that. 4 minus 6. So 4 minus 6 gives me negative 2. And then negative 2 plus 7 is 5. So that's my answer, negative 30x to the 5th. 22 we don't have to do because it's the exact same problem. That was pointed out to us. Awesome. 23.
Will you take 20 if we don't write the x for the exponent?
What do you mean? Oh, you just had an exponent to the... No, make sure you have the x, because that's what's raised the exponent to 30 wouldn't have been. 23. X squared, y to the 3rd, x to the 5th, y to the 2nd. Okay, we're going to combine the like bases together because they are multiplied. So I have x and x squared and x to the 5th. That gives me x to the what? 7th. Okay, and then y to the 3rd, y to the 2nd, like bases being multiplied. So what do I do to the exponents? Add. There's my answer. That all right? 24. I get 5x y times 2x squared y to the 3rd. Okay, so I'm going to multiply the 2 and the 5 together and I get 10. Is that okay so far? That's really x to the 1st. So x to the 1st times x to the 2nd is x to the 3rd. Okay. Last y to the 1st was y to the 1st times y to the 3rd. Y to the 4th. Right? Did I do that right?
Yeah.
You feel comfortable with those answers? May I move on? Last two problems? Okay. Number 25. So I have this grouped times this. And this is where a lot of you said, hey, I don't quite understand, which haven't covered this yet, but let's see if we can maybe work through it. So let me ask you all this. Let's see if we can figure this out. Let's go with the highlighter.
Did y'all say 10x to the 10th power?
Yeah.
Okay, let's take a look. Let's take a look. So can everyone see that yellow highlighted part?
Yeah.
Okay, so that whole quantity is raised to what power? The 2nd, right? It's raised to this power right here. You agree? Okay, so how many times am I multiplying 5x squared together? How much? So think about it. How many of these are there? 2. So that's 5x squared times 5x squared. Yes, I still have this. So where did both of these just come from? Yeah, that pink 2. That said, hey, you're multiplying those together twice. Does that make sense how I have that written up there? That's not the answer yet. I'm just trying to show you the work that's going behind it. Does that make sense? Okay? All right, so now we can go ahead and do the math. So let's combine 5 times 5 times 2. What's 5 times 5? 25. What's 25 times 2? 50. Okay? And now I have the x's. They're all being multiplied together. So what do I do to the exponents then? Add them. So what's 2 plus 2 plus 6? 2 plus 2 is 4, plus 6 is 10, right? Is that all right? And then, let's see if we can apply this exact same property to how number 26 is written. Number 26, I have 2x squared raised to the third. Then I have 3x to the third raised to the second. Okay? So how many times should I write 2x squared out? 3 times, because it's raised to the third power. So I have 2x squared times 2x squared times 2x squared. Now the question comes, where did all those 2x squareds come from? Well, this told us, hey, they're being multiplied together 3 times. Does that make sense? So how many 3x to the thirds are going to come along with this? 2 times 3x to the third times 3x to the third. So does this make sense that, let's do this later, that this here made that happen? And then that this here made this happen. Does that all make sense how I just wrote that? So now you just have kind of a string of things to multiply together, right? So if we go through it slow enough, you should be able to do it. So you got 2 times 2, that's 4, right? And then 4 times 2 is 8. And then 8 times 3 is 24. And then 24 times 3 is 72. Did I do my math right? Seem okay? Now I have all these x's. And they're all being multiplied together. So what do we do the exponents? Add them. So I have 2, 4, 6, right? And then 6 more. So I have x to the what? 2 plus 2 plus 2 is 6. 6 plus 3 is 9. 9 plus 3 is 12. Ladies and gentlemen, that's the assignment. Is there anything that's sticking out on there that's kind of a sore thumb other than number 10? Yeah.
Property of exponents said that. It says like x, m, n.
Oh, that was the property we've been working with. So yesterday, these were the 2 properties that we focused on. So that's all it was. It was just saying, hey, you have those are the 2 properties that we're working on this worksheet. For which one? Because that outside 2 says, hey, you're multiplying 5x squared and 5x squared together. That's why I did it all in the pink highlights and stuff. But we'll cover a lot more of that. That's like power to a power of a group is what's taking place. I'll try and cover that a little bit more. Hopefully I think today, nope, tomorrow we'll actually cover that property. X to the m raised to the n. So you're multiplying. That's exactly right. Okay, but so the difference between this one versus this says because of that rule this m times n. But what the rule that we kind of have on there is, let's say we had 3x to the 4th to the 2nd. So this just says, hey, if I have a base of x, but now I have a base of x, and I also have a base of 3. So really what's happening with that, just this comes here and this comes here. So it becomes a power to power. But we'll cover that more tomorrow, okay? All right. Make sure your name, first and last, is on that paper. Separate it from the packet. Pass it forward, please. If you don't pass it forward, I can't give you points.
Yeah, I gave it a brush.
So we're gonna use the notes from yesterday a little bit, but I took the one screen, which was this one, and I made it larger. So I'll pass this out. So this will be kind of what your notes will go off today, as well as tomorrow. So I want to cover the last couple of properties. So I'll cover 3 properties today, and then 2 properties tomorrow, and then we deal with, or maybe tomorrow, scientific notation. I can't remember. I got some sort of game plan in mind. So ignore the fact that it says January 8th at the top of it. We all know that it's the 10th.
I didn't know.
It's the 10th. Oh, thank goodness.
I
Please
know.
let me know.
Yeah, my birthday is on Tuesday. Are you kidding me? It's okay because at least you have Monday off, so it's fine.
I just had a birthday as well.
Happy birthday!
Yeah, it's too late.
Happy birthday. When
Too
was
late.
it? When was it?
December 30th.
Oh my gosh, that was a long
I
time
came
ago.
here. I thought y'all would bring me cupcakes on the 30th. No one showed.
That was a long time ago.
I know. It's so last year.
Wait, what? Is that so
I'm gonna do this later.
You should have cupcakes on Sarah's birthday. Yeah, will you please?
No, you bring your own cupcakes.
Please, hey, I'm like me and Chris are like your favorite people in life. It's my birthday.
Don't you ever threaten me like that again.
It only comes
Blasphemy.
once a year. You have to cherish it.
Cherish it.
Make me feel
All right.
so special.
So, guys and girls, I'm gonna go to this page. Actually, I'll go to this page. So these are the 2 we've already covered as of yesterday. Yes? If you weren't here, watch the video. You will see that we covered it. So now I'm gonna focus on the next 3. So I'm gonna focus on this one first, which this is you have an x in the numerator and an x in the denominator as far as the fraction. And they say they subtract. But we're actually going to call this one Tug of War. You guys, you know that game? It's now illegal to do because somebody in California lost a finger.
No,
They lost a finger, but the
Yeah, like we're not allowed to do tug of war in school anymore because there's some kid like I'm gonna wrap my pinky around this rope and 26 people are gonna yank as hard as they can. So now they made so you have one person who loses a finger. So let's apply it to everybody. It's too dangerous. People losing fingers. Talk with one person. Doesn't matter.
Wait, so it's illegal now?
Yeah, that's why we don't do tug of war at assemblies or.
Oh my gosh, we should have a field day.
I know we should, but then I'd get in trouble for doing tug of war because someone lost a finger.
We always did like melt the parachutes would always.
Huh? Oh yeah, and wave and get under it. They'll look at each other and it's all colorful.
Parachute with Miss Hanson.
All right.
She was so nice.
I loved Miss Hanson.
Me too.
I have no idea who that Miss Hanson is.
She has the cutest kids.
Okay.
I think they're
All
like.
right. Well, can we progress, please?
Yes.
All right. So we have 2 on top of each other, and we're going to call tug of war. Okay. And I think it's going to make sense once we go through it. So notice our very first problem. We have 2 to the 15th on top. Still with me? And you have 2 to the 7th on bottom. So now when I say tug of war, we're going to do this. Who do you think would win in a tug of war? 2 to the 15th or 2 to the 7th? 2 to the 15th. Does that seem like logical to say that? Okay. Now, so the top is going to win. Does everyone agree on that first problem? Does that make sense if I say that? How many will the top win by? 8. Good. So this becomes 2 to the 8th power, and it's done. Okay? And you don't have to keep it as a fraction. You could say, oh, yeah, that's 2 to the 8th. Oops, I can't. 2 to the 8th power over 1. I could do that. Or you could just write 2 to the 8 over 1 is the same thing as 2 to the 8th. And notice I kept it as 2 to the 8th. I didn't go multiply it out. Okay? I think it's 256, I think. But it might just because I've taught math way too long. Yeah, you subtract them. All right, so let's look at the second problem. Okay? So I have a tug of war with the x's. Who wins, top or bottom, on the second one? Who wins with the X's on Tug of War? None of them. It ties, right? They cancel each other out. Who wins with the Y's, the top or the bottom? I have y squared on top, y to the 5th on bottom. Who wins? Bottom by how many? 3. So this becomes 1 over y to the 3rd. Because you said the bottom one, right? And I need to keep it as 1 over, because 1 over something is a little different than something over 1. Agree? Math literacy. Okay, so I think we're good there. Let's find some more tug of war. Oh, another tug of war here. Who wins, top or bottom? Bottom by how many? 8. So this becomes 1 over 2 to the 8th, because you told me bottom 1. So 1 over 2 raised to the 8th power.
Oh my god. Wait. And then you don't have to do it when the top wins, and it's just like.
There you go. Okay. Let's see. I'm looking for more. Oh, here's another tug of war. Who wins on this one? Top by how many? 2. So I just get a to the 2nd. Yes, I could keep it as a to the 2nd over 1, but I don't need to. Another tug of war. Oh, this one could be a tug of war. So first thing, now we have numbers we're introducing. So what's 18 over 6? What's 18 over 6? 3. Good. All right. Tug of war with the X's. Who wins, top or bottom? Bottom by how many? This is x to the 1st, though. So how many does it win by? 1. So I get 3 over x, or you could put 3 over x raised to the 1st power. The 1 can be raised to the 1st. Same thing. Let's see, looking for more tug of war. I'm skip these because those are raised to the 0 power. Don't worry about negative exponents right now. Oh, what about this one? Who wins, top or bottom? Bottom by how many? 10. So I get 1 over a to the 10th power. Okay. Negative exponent I don't worry about. Scientific notation, scientific notation. I'm going to do that. Oh, tug of war right there. Who wins, top or bottom?
Top.
Top by how many? 5, so I get x to the 5th. Okay. Oh, this one's a. Oh, I have a negative exponent. Let's don't worry about that. Negative exponent, not going to worry about now. Cool. That's that property. So, if you have a fraction, and you're not dealing with any negative exponents, you can have a negative base, so you can have like a negative 5 or something, but your exponents aren't negative, you do a tug of war. And you literally use the thought process, who wins, top or bottom? And you answer the question that way. And then whoever wins, how much do they win by? We okay so far? Okay, so we just covered that property. This next property, something to the 0 power. If you have a base, and that base could be a letter, if it's all grouped as a quantity, it could be a whole quantity. If I have something raised to the 0 power other than 0, because 0 to the 0 power is actually undefined, but if you have a letter or a number raised to the 0 power, the answer is 1 for that portion. Okay? For that portion. So let's take a look back at our sheet. We'll do these in blue. Okay, we're looking for negative exponents. Or we're looking for a 0 exponent. So let's come to our first one right here. So this whole part right here, that whole part, I have d to the 3rd raised to the 0 power. So what does that, what I just underlined, have to be? What is this that I just underlined have to be? That yellow part right there is going to just become 1. Okay? Now, that part became 1. Now, this part, I have power to a power. So, power to power, exponents on top of each other. This is yesterday's rule. What do? Multiply. So this becomes d to the 10th. So I get d to the 10th. And if I were to take d to the 10th and multiply it times 1, what would I get? D to the 10th times 1. What do you think I get? D to the 10th. So the answer to this one is just becomes d to the 10th power. Done. Okay? We're looking for a 0 exponent. So let's take a look on this next one. Let's highlight here. Okay? What is y to the 0 power? What is y to the 0 power? Anything to the 0 power other than 0 is? No. 1. So this becomes 1 over 1. And what's 1 over 1? Just 1. So looking for 0 exponents. Oh, this is a good one. Oh, this is always a gotcha, and I promise you'll see this problem on the test in a quiz. Okay? See that whole quantity? There's a lot there. That entire quantity is raised to what power?
0.
To the 0. Anything, including a quantity raised to the 0 power, has to be what? 1. That answers 1. Promise you will see that question on test and quiz. And it's one of those where it sticks out. It's going, oh my gosh, look at how enormous that problem is. It's 1. Okay, here's another one. This entire quantity is raised to the 0 power. So what's the answer to this? 1. Look for more 0, exponents of 0.
What if it's a non-exponent?
So it's like 7.
Like, yeah. it would be like
7 raised to the 0
1.
power is 1. 155 trillion, 244 billion, 221 million, 441,000, 221.787332 raised to the 0 power is 1. Nick, you don't have to write that big old example. All right, 0 power. Here's a 0 power. So what part of this problem is raised to the 0 power? Is the 8 and the y, or just the y? Just the y. So what does y to the 0 have to become? 1. So then this becomes 8 times 1. And what's 8 times 1? 8. Done. Okay, 0. Oh, this one's raised to the 0. So what's raised to the 0 on this? The y, okay. All right, so the y, so that's the only part that's 1. So what's 8x squared times 1? What's 8x squared times 1? What's 8x squared times 1? 8x squared. Okay, and then you're going to multiply this and use yesterday's properties. So let's multiply the numbers together. 2 times 3 is 6. 6 times 8 is? What's 6 times 8? 48, thank you. So we get 48. Okay, I have x to the 4th, y to the 4th. I can't combine those together. I have x to the 2nd, x to the 2nd, or x to the 4th and x to the 2nd. So what do I get with the x's? Like bases being multiplied, so I do what? Like bases being multiplied, what do I do with the exponents? Add them. So 4 plus 2 is 6, so x to the 6th, and then the y to the 4th comes along. So that problem has that for an answer right there. Ooh! Whole quantity raised to the 0 power is? 1. What's raised to the 0 power here? The y. So y to the 0 is? 1. So that becomes negative 12 times 1. What's negative 12 times 1? Negative 12. And we're done. That's how the 0 property works. So watch out. See to what term is raised to the 0 power. It could be an entire quantity And the whole quantity is raised to the 0 power, and the whole thing becomes 1, or it can be individual parts. Okay? Am I doing okay? All right. And the last property I want to cover for today is this. If I have a negative exponent, okay? If I have a negative exponent, it wants to move where it's located. If that negative, so let me clarify this first. If I had 3 to the negative 2 power, could I put 3 to the negative 2 and have the whole thing over 1? So I can make any number a fraction just by putting it over 1. Do you agree? I can make any number a fraction just by putting that number over 1. Does that make sense? Okay, so we're going to focus on that. So let me just decipher this a little bit. If I had x to the negative n is equal to this, that means that I could take that and put it over 1 and it's still the same thing. So all you're doing is, if you have a negative exponent, if it's on the bottom, it needs to move to the top. If it's on the top, it needs to move to the bottom. Okay, so let's go to our grid and take a look for negative exponents. Negative exponents. Oh, here's one. I have x to the negative 5 over x and x. So x to the 5th wants to move down. So I get x on top, that stays on top, over x to the 5th. Ooh, what does that now become? Fraction. And I have an x on top and I have an x on bottom. So we have a tug of war. Who wins on that one, top or bottom? Bottom by how many? That's x to the 1st though. 4. So I get 1 over x to the 4th. That's the answer there. Oh, that's the tug of war. Okay. Oh, shoot. I have a negative number and I have a negative exponent. The negative number is going to always be a negative number. But the negative exponent we can change. So this is going to become 1 over negative 3 squared. Okay? What's being squared? The negative or the 3? The 3, so then this comes out to 1 over, or negative 1/9. Looking for negative exponents. Oh, I have a negative exponent here. What's negative? Is the 2 and the y, or is just the y? Just the y. So I'm going to wind up with 2 over y to the 4th. 2 over y to the 4th. I have a negative exponent on bottom. What's going to happen? What's the x to the negative 3 going to do? It's going to do where? It's going to move up. So this wants to move up. So this becomes x to the 3rd over 1, which is just x to the 3rd. Go ahead.
So if there's a negative exponent, it would automatically be positive.
When it switches spots.
Oh.
When it moves from the top to the bottom, or it moves from the bottom to the top.
Oh.
So there I moved it from the top to the bottom. Here I moved it from the bottom to the top. When you move it, when it switches positions, it's no longer a negative exponent. I have a negative exponent here, so what's my answer? So the x to the 4 wants to move up, so I get 6 x to the 4th.
Which you just flip it?
Just move it up. Yeah, you don't flip the whole fraction. You just move whatever was negative. Hey, on this one, this will be my last example I'll do. I have tug of war with the x's as they sit. Do you agree? But what happens with the y's? The y to the negative 8 moves up, so I get y to the 8 on top. So I'm going to bring this down here. So I get y to the 8 on top, and then I get y to the 6 on bottom. So you would have had x to the 3rd, x to the 5th, tug of war. Who wins on the x's, top or bottom? Bottom by 2. Top wins by 2, so I get y squared over x squared. And that's this problem here. Okay? Ladies and gentlemen, I think you have enough that you will be able to complete pages 3 and 4. pages 3 and 4. Pages 3 and 4. A great deal of you all had top marks today. Keep it up.
Thank you, Mr.